Hello everyone. In order to calculate the 2-deck sheet carrier density in high electron mobility transistor or HEMTs, what you will need to do is to, at first, you will have to open the structure file that you have already simulated. Let's say we are using this structure. Okay. And now we'll have to make sure where the two-dimensional electron gas is supposed to be formed. In this high electron mobility transistor, it is supposed to be formed in this heterojunction. This is the high bandgap material, aluminum gallium nitride, and the below one is low bandgap material, gallium nitride, the channel here. Then you'll have to go to the tools and take a cut line under the gate. You'll have to make sure that you're taking the cut line under the gate, and it should definitely cut this heterojunction where 2-deck is supposed to be formed. Then go to this screen, select this screen, and you'll have to unselect this. We'll have to check conduction band energy, electron quantum Fermi level, and valence band energy. This is the energy band diagram of the heterojunction, and this is the two-dimensional electron gas. Now what you will need to do is to calculate the depth of the 2-deck. So you will have to take this ruler from the tools option. Okay, actually this is the two-dimensional electron gas at 2-deck. Now we are measuring its depth. Okay, see at the left hand side of the screen you are seeing an angle. You'll have to make sure that this angle is 0. That means your line is straight. Okay, so it's almost there. Okay, so the length we have found here is this, and it's definitely in micron. In Silvaco, the default unit of length is micron. So you have to note this depth. Let's say we are putting it here, 277. Okay. You'll need this dimension later. It was 0.00277. Okay, and just convert it into centimeter. To convert a length from micrometer to centimeter, you'll need to multiply it by 10 to the power minus 4. Okay, we'll return here later. Okay, now we'll have to zoom out first. Again, go to the display option, uncheck these options, and you'll have to select electron concentration. Uncheck this one, uncheck all the options, and select the new one, electron concentration. The electron concentration is shown here in per centimeter cube. As you know, 2-deck is a two-dimensional plane, so the electron density or charge density should be in per centimeter square. We have already noted a dimension which was in micrometer. We have converted into centimeter. Now you are getting the electron concentration here in the 2-deck, which is in per centimeter cube. If you multiply this per centimeter cube value with the previous centimeter dimension, you get a value in per centimeter square, which refers to the 2-deck sheet carrier density, which is in per centimeter square. So the maximum charge concentration, which is around, actually this y-axis is in logarithmic scale, so every value you are seeing here needs to be powered by 10. So here we are seeing that the maximum electron concentration in 2-deck is 10 to the power 20, and which is in per centimeter cube. Now multiply this value with the previous one, 10 to the power 20. Okay, actually this value was in centimeter, and this is in centimeter cube, per centimeter cube. So the result you are getting is in per centimeter square, which refers to the electron density in the two-dimensional electron gas, which is like a two-dimensional plane. And we are getting here the sheet carrier density of the HEMT here is 2.77 into 10 to the 13, which is a typical value for HEMTs. So this is how you can calculate the 2-deck sheet carrier density in case of HEMT. Thank you.